Welcome back. In this video, we're going to go ahead and continue the configuration on the customer switches. This time we'll be working with customer 2. We'll work with customer 2 site 1 and customer 2 site 2. That's CE2A and CE2B respectively. So our previous video, we configured customer 1 and we saw BGP set up there, and we actually had full routing going between sites. This time we'll do the same thing, but we'll do it for customer 2. So we'll be working mainly just on CE2A and 2B, and then we'll briefly look at PE1 and PE2. So we're going to go ahead and go back to the command line now. We'll go to CE2A. And the first thing we're going to do is apply the base configs. And like I've mentioned before, the base configs are available in the lab workbook, and that's all the way down in the appendix. Okay, and I paste this in sections just because sometimes there's too much config. It'll overrun the buffer, and then it'll start pasting it in incorrectly. So I do just do sections like you saw there. Okay, so we've got CE2A, the base config is on. At this point, what we need to do is we need to go ahead and just configure the interfaces. So let's start with the interface configuration, and then we'll move on to the routing after that. Okay, so just like we saw last time on customer 1, we'll be doing similar on customer 2. We've got the loopback. This time we'll have 172.17.0.1/24. That'll be the IP address for loopback 0 on CE2A. What this will do is, again, just it'll emulate a customer network. And we do that because if we were to do an SVI, we don't have anything connected, that VLAN would go down and it wouldn't advertise the route. So we use the loopback. So we'll go ahead and configure 172.17.0.1/24, and that'll be loopback 0. And then on gig 101, we'll configure 192.168.1.0/30, and .2 will be the address on that side. I will set the IP address and the description. We'll go in at a gig 101, which is the one that's going to connect to the PE. We'll do no switch port, and that'll make it a layer 3 interface. And then we'll go ahead and activate it. Okay, now we want to just check the status of the interface. And we'll do show in gig 101. We can see that that interface is up and it's connected, which is exactly what we want. So our next step would be, like we've done before, we're just going to go from CE2A, and we're going to try to ping PE1 across its transit interface there, the transport. 192.168.1.1 is what we'll try to ping. And we can see that we're able to ping all the way to the other side. We get 100% success rate. So that is a good sign. At this point, that means we're ready to start working on our routing configuration. So let's go back to the diagram. We'll see that now we're going to be working with BGP. So this site here has a local ASN of 65535. We'll be peering to 64512 using eBGP IPv4. So we are going to be peering to 192.168.1.1. That's right here. So we'll set up BGP with ASN 65535. We'll set the router ID to be the loopback 172.17.0.1. Log neighbor changes. Set the remote AS 264512. That's who we're going to be pairing with on 192.168.1.1. Like we've done before, we'll set a description. Reason we set descriptions obviously is to know what it is, and it seems kind of trivial here, but for a PE router, or even here we're on a CE router, if we ended up having a lot of different BGP pairs for whatever reason, it's always nice to have a description. That way we know exactly what's going on there. Makes it really good for an operational team to be able to go in there and just figure out what's going on right away. Set our password. Set the timers to 5 and 20. We'll go ahead and activate it. So the 172.0.0/24, again, that's our loopback 0. That's what we want to advertise out. That's going to be our customer network. So we'll advertise that. And we've got our transport also. All right, so let's look at our BGP config here. And now we can see that we have this set up, ready to go for 192.168.1.1. So all the necessary configuration is in there. Let's go ahead and see if we have a session established. All right, and we do. So about 1 minute and 5 seconds it's been up, and we're learning 2 prefixes. Okay, so now that we know our peers up, let's go ahead and see what routes we're learning and what routes we're advertising. So we'll see what we're advertising here. We'll see we are advertising the 2 routes that we want, the loopback 0 and again the transport. And let's see what we are learning. And there we go. Those are the routes that we're learning. So this is a good sign. We've got customer 1 configured now. Customer 2 site 1's configured. And now we want to configure customer 2 site 2. So let's take a look here. We've got CE2A done. It's working. We have an adjacency over here to PE1. So we'll go on to CE2B now, and then we'll go ahead and configure that. So what we're looking at here, again, is we're going to put on the base config and then put on the IP addressing. Again, the base config is in the appendix of the lab workbook. The loopback 172.17.1.1 here, /24, and then the gig 101 transport 192.168.1.4/30, and we're going to be .6 on this side. So let's go to the command line and let's get that going. Okay, now we've got the base configuration all loaded. Let's go ahead and build up the IP addresses on the loopback in the gig 101. Okay, 172.17.1.1/24, that's the IP address on loopback 0. Now let's configure gig 101. do the no switch port, make that a layer 3 interface first. Okay, so we got gig 101 configured and our loopback 0. So let's take a look now at gig 101. All right, and just like we've seen before and exactly what we want to see again, it is up connected. So that's very good. And we'll try to ping the other side. Okay, so we can see now that customer 2 site 2 can ping all the way over to PE2 across the Ethernet connection that's there. So that's good. Let's go ahead now and we're going to configure up routing. Save our changes and let's look at the diagram. So we need to set up routing again. Now this one here, we're going to be ASN 65535, and if you recall from the previous videos, and what you'll notice here is that the ASN is the same between site 1 and site 2. And we did that because that was, again, one of the scenarios that happens out there in the industry where customers will use the same ASN over and over. And like we saw on the PE side, we had an additional command on there, the allow or the AS override, and that command was set up on there. So we'll look at what happens with that during our testing. But as far as the BGP session, we're going to have ASN 65535. And we're going to go over to PE2, and that's to ASN 64512. And you'll see here the 192.168.1.4 will be peering over to .5. Okay, so let's get on the command line again. Put a BGP router ID. Six 64512. Set a description. Set up our password for authentication. Set up our timers. We'll allow it to send a community, just a standard community, and we'll go ahead and activate it. Turn off auto summarization, and we need to advertise our networks. Otherwise, we won't get routes across. So we're going to advertise loopback 0, 172.17.1.0/24, and we're also going to advertise the transport. And there we go. Save our changes. And now we want to make sure that we have a BGP session. Okay, and we do, just under a minute with 3 prefixes learned. So let's make sure that we have the right routes that are being learned and advertised. Okay, so we are not advertising anything yet. Let's see why that is. Sometimes it just takes a little bit of time, or sometimes it's because we've made a mistake. So we'll take a look at that. Okay, so we are learning the routes, which is exactly what we want. There we go. And so it just took a little bit of time. You saw the first time here we ran it up top here, and it said that we weren't advertising any prefixes. However, after a little bit of time, you saw that we are. So now we are advertising these 2 prefixes down here. So that's a good sign. It does take a little bit of time, so don't panic if you don't see it right away. Sometimes it'll take 30 seconds or so, and then it'll start. So you can see actually we had a neighbor up for 51 seconds here, And it is even a little bit longer once we enter the commands, and we still at that point hadn't advertised any routes. So just give it a little bit of time to do that, and you'll see here now that it is working. So let's take a look at our routing table and see what routes we've got in there. Okay, so that's the full routing table. We could do show IP route BGP and just see what we're learning through BGP. We are learning the remote sites. So we're learning the remote sites LAN network, which we assigned as a loopback, and also the transport. So let's make sure that we can ping that. And we always want to ping from our loopback, and that really gives us a good test end to end. We know that our customer networks are communicating. And there you go. We can ping all the way from customer 1 to customer 2, and we get a response back so that we know bidirectional communications are working properly. So on here, we'll see that customer 2 site 1, he's pinging all the way from there through the PE down to PE2, and then back over to site 2, and then we can ping back and forth. So that test is working correctly. What we want to do though is I want to show you a couple of things, a couple of differences now with the ASN being 65535 using the AS override command. So let's take a look here. So we can look at our BGP table here. And what we really care about, we want to look at the 172.17.0.0 network because we're on CE2B. And what you can see is the path here, it has AS64512 and then another instance of 64512. Now, if we didn't have the AS override here, obviously it wouldn't work because, like I said, the loop prevention. However, if we were to actually go over and take a look at customer 1, so if we go back to the diagram here where this is the same AS, right, 65535 on customer 2, they both have the same AS, the PE1 or PE2, depending on which router we're looking at, would go ahead and strip off whenever a route's received, for BGP updates received it, we'll go ahead and strip off the ASN that we had from the customer, and it'll replace it with our own. Now that's not necessary on customer 1. So on customer 1, we would actually see the ASN the ASN path, the BGP AS path all the way through. So why don't we just take a look at that real quick on customer 1 so you can see the difference. So here you see that the remote site customer network is basically 64512 and then a second instance. So it goes through 2 AS paths to get there, just puts it both on there. Okay, so we're on customer 1, site 1, CE1A. And now if we look at BGP here, we can see that we're learning the 172.16.1.0/24 from his other site. But you'll notice that it says 64512 and 65001. So it originated from ASN 65001, then it went through AS 64512. However, up top here, scrolled up a little bit, you'll see that it stripped off the originating AS for customer 2 and it applied 64512. So it does keep the amount of AS paths in there, the number of paths that's gone through, or the hops that it's gone through. So that way it can be used for just for route determination and what's the best path for best path selection. However, here where we don't have the AS override, we do see the originating ASN. So that's exactly what we want. That's the difference there, and that's really the main thing. All right, so for one last step here, what we'll do is we'll go back to the provider routers and just look at it from their perspective. So we were looking at the customer 2 from the customer's perspective, and we want to now look at it from the provider's perspective. So show IP, BGP, VPN, v4, all summary. Now you'll see that this neighbor here, 192.168.1.2, his AS is 65535. It is up. It's been up for about 22 minutes or so, and we've got 2 prefixes. So we can also do the same thing on PE2. And you can see here that we also have a neighbor up. And from the provider side, we can also, if we wanted to, look at the customer routing table. So we can do a show IP route VRF and then the VRF name. Then we would see whatever routes get put in the routing table there because this is a provider edge router. So we could do that for C1 and C2. And then we'll actually see what's in the routing table there. So that's pretty much it now for what we've got on the PE and CE configuration. So we finished the customer configuration, and this is all being done for IPv4. So this is a fully functional network at this point. The customers, we have 2 customers working across an MPLS backbone. If we needed to, we could add in additional customers on here. If we wanted to expand this out, we could add quite a large number more customers. If we wanted to expand out the provider backbone, we would just simply add some more provider routers in there, some P or PE routers, connect everything together, and then it would grow and we could just continue to add customers. And that's really the benefit of MPLS, is being able to add in a lot of different customers over common hardware. So we don't have to stand up a dedicated network for every single customer, and we also give some additional functionality there. I mean, we can run it's like multi-point. We don't have to have a big hub and spoke like traditionally was done, and it's just really powerful way to set up connectivity, and it's a lot cheaper for the provider because they don't have to have so much equipment, and it's a lot cheaper for the customer because some of those savings are passed on to the customer. And so it is a preferred model. It's something you'll see very frequently in the industry today. Many companies will actually tie into a service provider. So learning service provider network like we're doing here is beneficial because it's a great place to go to do networking if you want to do a job as a network engineer or operations or architecture or whatever. A service provider is very good. They pay very well. It's usually a very stable job, and it's something that is growing because everybody needs communications. So this is important to learn. It's a good topic to learn, and I'm excited to be able to teach this to you. So at this point, we're going to go ahead and stop the video. Our next video will look at some additional services like you've seen here. We've got IPv6, and we'll set up some IPv6 on the next video. There's some work to do on the provider backbone, so we'll go through that. And there's also obviously work to do on the customer equipment. So it's similar to what we did with IPv4, but we'll be doing it with IPv6. And then once that video is done, we'll also be doing some other videos here on layer 2. So we can provide some layer 2 services, and we'll do that for customer 2, and we'll go through that also. Okay, so we'll see you back in the next video.